Good morning, Joe.
Morning. How are you?
Okay, Joe. So will you be going through our homework?
I will teach first. I've got a last part to teach, and then after that, we will see how lah. Okay.
I only did until section B, Joe. Section C, I do not know how to do.
Okay. If we don't have time to do it here, then you ask me on Edmodo lah. Then I will guide you all from there. If we don't
Okay,
have
Joe.
time lah.
I wrote to you on that model, so I explained that I don't know how to do section C.
Okay. I will have a look at it, and then I will reply to you there. If we don't discuss
Okay,
today.
Joe. Okay, Joe. Thank you.
Okay. And yeah, my Edmodo, the messages are not coming in. I'm not sure why. So it might be delayed. So if I don't reply quickly, then there is probably an issue.
Okay, Joe.
Okay, so just maybe wait, give it 1 day or so lah. Okay, make sure you all have your geometry set with you all. Take it out, put your pencils in and set it all up. Yeah, okay. If some of y'all want to draw it on A4 paper, you can get your A4 papers. If not, you can also do it directly in your book.
So do we need those Jeremy? Do we need those triangular rulers?
No, triangular rulers, no, just normal ruler.
Oh, okay.
Okay, I'll take attendance and then we can start. Just give me a moment. Okay, let me just take attendance. Isaac? Is Isaac here? Yes, okay. Isabel is not here. Okay. Abigail? Here. Carlos? Carlos not here. Okay. Elijah?
Here, Jeff.
Kavishka?
Here, Cha.
Ricardo?
Here, Cha.
Celeste? Celeste is not here. Pooja? Okay. Surika? Oh, Surika not here. Okay. Aaron Look? Here. Zarit? Here. Michelle? Malcolm? Jared?
Here, Cha.
Judith?
Here, Cha.
Okay. Okay, let's start off. Okay, so we're going to look at something called loci, locus or loci. So this is something similar to construction, when we did the perpendicular bisectors and stuff like that. It's something similar to that. And we are, there are four main, like I guess, rules or four main things that we will look at in this chapter. I mean, in this part. Okay. Yeah. So, just give me a second. If you have your textbooks, please get your textbooks. Let me just see what page it is at. Okay, so it is on page 145 of your textbook. So basically, when we look at locus or loci, we're looking at many different possible positions a point can be at. Okay, so we have a rule, and then based on the rule, there are possible solutions, possible points, um, um, possible points to which is related to the point of reference. So we want to look at all those possible points. That means there'll be more than one. So it will be like a region of points. Okay, so yeah, let's look at the first one. Okay, so let's say I have a dot, and then I call the dot A, and I want to draw a locus of the points 6 cm from A. So if I were to draw points 6 cm from A, it could be here, it could also be here, it could be here, it could be here, it could be everywhere. So there'll be a circle of points which are 6 cm from A. So there are so many possible points, 6 cm from A. Okay, so let's start drawing. Okay, so you can write the title loci. Okay, and you can see that the locus of a rule is all the points that rule. So you can start with the description, and then you do number one, you do the circle first. Write the description there. Put a dot in the middle of your page, call it A, and then draw the locus of the points 6 cm from A. Okay, start drawing. Your time to draw. If you all want to refer, it is on page 145 or 146 of your textbook. Okay, can I see a show of hands who are still doing number one? Okay. I'll give you 1 minute more. Okay, let's look at the next one. On the right, so I have a line across the center, and I want to leave
Yeah,
dots. Yes?
You know the first one actually, it can those dots can be anywhere on the circle.
Sorry? Yeah. It can be anywhere on the circle. It's just that the whole circle a circle is, or a line is made up of points, correct? So the whole circle has encompasses points, possible points that are 6 cm from A, yeah, because it didn't say, okay, 6 cm from exactly north of point A. You know what I mean? So there is a whole circle of points where it is possible that that point is 6 cm from point A.
Okay, Joe.
Okay. Okay. It has to be 6 cm apart. So how you draw 6 cm is like how you draw a circle of radius 6 cm. So remember when we did construction, we take a compass, we take the ruler, and then 6 cm, and then we draw. Okay? If it's 6 cm, 6 cm. If it's 8 cm, then 8 cm. Okay, next we have a line across the center of the page. And I want to leave lots of space at the left and the right. And I want to draw the locus of points 4 cm from the line. So 4 cm means if I were to take a ruler and measure 4 cm, I can put a dot there. I can do a point here, 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 like that. And I can do on the left and right hand side as well. So I have a shape like this. So this one, you won't be able to draw like using your compass, because then you would get a circle. But what you do is from different points from the line, you take your ruler and mark different points, which is 4 cm from the line. And then you connect the dots.
Yeah. Yeah.
Yes?
So that whole circle there is 4 cm from the line.
Yes. So this, well, in this case, this is not a circle lah. But yeah, this whole thing is 4 cm from the line. So this point is 4 cm from this part. This point is 4 cm from here. This one is 4 cm from here.
Is the line 4 cm?
This line, the blue
Yeah.
line, no, the blue line, no.
Okay.
It's just that from the line to the points, it's 4 cm. So here. This is awesome. So you want to label this as well, so that, yeah, you know what does it actually mean. Okay, I'll give you another 1 minute and then we will go to the next one. Okay, let's look at the next one. Next one, I have 2 points 12 cm apart, calling them B and C, and I want a locus of points equidistant from B and C. That means they must be equidistant from B and C. Basically just means that the line has to be what? If I were to draw points that is same distance, let's say I have a point somewhere, the distance from B to that point must equal to the distance from C to that point. So what does that mean logically? Anyone?
Sir, can you explain again what locus is?
Well, so locus just basically means there is a rule, and you want to find points, possible points that adhere to that rule. So in this
Okay.
case, for example, right, for number 3, I have these 2 points, B and C, that are 12 cm apart, and I want possible points that are the same distance from each other. So between the B and that point is the same distance as C from that point. So what would that mean? Where would the point be?
Maybe it might be here, sir. Like you must measure 12 cm,
Okay, and then?
and it could also be here.
Okay, so basically it means that, for example, from here to your bedroom. Okay, so where you are at now, and if you're in your bedroom, maybe there to your kitchen lah. From your bedroom to your kitchen, so your bedroom is one point, your kitchen is another point. Okay, then I ask someone to stand in a place where it's same distance from your bedroom to that place where the person is standing, and from the kitchen to the place where the person is standing. So where must the person stand? So I'm saying stand in between the kitchen and the bedroom, and it must be same distance. So if I were to walk from that point to the bedroom, it must be same distance from if I walk to that point, from that point to that kitchen. So he
Means
has
he
to
has to
stand,
stand like in the midway,
correct,
like
right
half.
in the middle, exactly half, correct. So if I have points that are equidistant from B and C, it could be here, it could be in a place where I have, okay, 1 point there, that's the middle, and then I have a perpendicular bisector. So right in the middle, so between B and C, the line B and C, remember perpendicular bisector cuts the line into half at 90 degrees. So again, see, I have, that's the middle point, and then there are many possible points. So I cut, and then I cut the other side, and then I will have many points. So that whole line is possible points of the locus from which it is equidistant from B and C. So how you want to draw that is, yes?
Right, you want to explain. I was going to ask you how to
How
draw.
to draw is, first you draw 2 points, B and C. Make sure they're 12 cm apart. And then you mark the middle between B and C. So you mark 6 cm. Okay, after you mark 6 cm, you take your compass, and just a second. You open it such that it is, or you put it at point B. You put the sharp point at point B. Okay, you put the sharp point at point B, and then you open the compass such that it is more than half. That means past 6 cm, so maybe 7 or 8 cm. And then you draw the arc. You draw this thing. And then you put the sharp end at point C. Using that same distance, don't move the compass, you cut on the other side. Then you will have an intersection, 2 intersections, and then you draw the line. Okay, can I understand? Everyone got that?
Yes, dear.
Yeah. Okay, you all will need to like reply to me. If not, I will take it as only Elijah is learning here. You all have to yeah, communicate with me. If not, I wouldn't know whether you all understand or not. Okay. And yeah, if your mics are working, you use your mics, because sometimes I might not be looking at the chat. Okay. So you draw a line, points BC 12 cm apart. You mark the middle, and then you open the compass such that it's slightly more than half. So put the sharp point at B, open the compass where it passes the middle. And then you stand on B and you mark. And then the same distance, don't move the distance. You stand at C and then you mark again. And then you will have two other intersections and then you draw a straight line. So any point on that line will be equidistant from B and C. Okay, can I have a show of hands of those who are still drawing? Okay, I'll give you another 1 minute and I will continue. Okay, let's see the last one. I have a rectangle and I have D, E, F, G as the corners. So I want the locus of all parts closer to line DE than DF. Okay, I want the locus, basically possible points of all the parts, listen carefully, closer to the line DE than the line DF. So let's look at this. Okay, so I have D. Okay, so I explained to you what they do. So they draw an arc here, and then they stand on this point of intersection, and then they draw with the same distance. I cut at the other, and I sit at this point, and I cut as well, and I draw a line. Okay, so these parts will be closer. So the points will be closer to the line DE than they are to line DF. So this will be a region of points. Okay, so rewinding back a bit. So how I draw is, I just take a small distance.
The arc can be any length.
Yeah, but open your compass to be small.
Okay.
Not very large. And then, I stand on the point D first, and then I make a whole arc. And then I stand on one intersection using the same distance I cut, and then I stand on this intersection and I cut again, and I draw a line. And then you don't have to color, you can shade that region. So all the points in that region will be closer to line DE compared to the line DF. Okay, so I repeat one more time how to draw, yeah? Just go back a bit. So I open my compass to be really small, not too large. And then I stand on point D, the corner, and then I draw a whole arc. Okay, and then I stand on this first intersection here. Let me just stand on this. And I make, with the same distance, with the same opening of the compass, I make a arc. And then I stand on the other side. And then I make another arc. And then I draw it, that connect point D to that intersection. And then I shape the smaller side because that's the closer side to line DE. Okay, can I have a show of hands of those who are still drawing? Okay, I'll give you all another 1 minute and then we will go to a question. Okay, let's go to a question now. Okay, so let's say I have a new 8 by 6 cm triangle, rectangle, sorry. Let me just clear all that. Okay, so I have an 8 by 6 cm rectangle. I want to, number one, shade the locus of points 5 cm or more than A. So point A, the rule is it has to be 5 cm, points that are 5 cm or more inside the rectangle. So outside the rectangle doesn't count. And then so on and so forth. So we'll look at it one by one. So, okay, start drawing the rectangle first, and then we will do one by one.
Gee, it's 8 by 6, right?
8 by 6. So AC is, I'm guessing 6 because it seems shorter. AC is 6, and then AB is 8. So the length is 8, the width is 6. So quickly draw the rectangle first. And then label them A, B, C, D. Make sure you label correctly. Don't get it mixed up because then when we draw, then we will have different points of references. Okay, I give you all 30 seconds to draw the rectangle quickly. Okay, so I have a rectangle. Can I have a show of hands of those who are still drawing the rectangle? Okay, so I have the rectangle. Okay, let's look at the look at the PowerPoint first, okay? Then I'll give you all time to actually draw, because you don't want to draw while I'm talking, because then you don't know what you're doing. Okay, so pens down, let's focus on this. I will give you time to draw. So shade the locus of points that are 5 cm or more from A inside the circle. So just now when we had a point and I wanted to draw locus of points that are a certain distance, we got a circle, correct? So, but here the rule is it has to be 5 cm or more. So it could be 5, it could be 6, it could be 7 cm. And then it has to lie inside the triangle. So if I were to draw a circle, half or 3/4 of the circle is outside the rectangle. So let's see. So I take a protractor, take a compass, sorry. I draw, I put it here and I measure 5 cm with my ruler, and then I draw a whole line here, and it will be this whole region. Why is it the whole region? Can anyone tell me? Why
Because they said
must it?
5 cm or more.
Correct, because it's 5 cm or more. So it's 5 and above 5. And it has to be inside the circle, inside the rectangle, sorry. That's why all the other points outside don't count. So you take a compass, measure 5 cm on your ruler, stand on point A, and then draw the arc, and then shade this region here. Okay, quickly do. Okay, can I have a show of hands of those who are still doing? Okay, then let's move on to the next one. Okay, number 2, it says, shade the locus of the points within 6 cm of A and 5 cm of D. Okay, before that. Okay, so I have this one is number 1, right? Can you all please write this down? Shade the locus of the points 5 cm or more from A inside the rectangle, so that you know that this is the question for your answer. Okay, quickly write that down. Okay, then once you're done, draw go to the next page and draw the same rectangle again. Because I think if we draw everything in one rectangle, it'll be too messy. So once you've written this down, go to a new page and draw the exact same rectangle, 8 by 6 with the points A, B, C, D. And then we will look at the next loci. Okay, let's go to the next locus rule. The rectangle is 8 by 6 cm. So the length is 8, the width is 6. And rectangle opposite sides are the same length. Okay? Okay, shade the locus of the points within 6 cm of A and 5 cm of D. Okay, the question is, you can write down the question as well. Shade the locus of the points within 6 cm of A and 5 cm of D. Okay, so it's within. So let's see, 6 cm of A. So that will be 6 cm. And then 5 cm of D. So from D, I measure 5 cm and I draw an arc. So it will be that region in the middle. So you shade that region. Because it has to now obey both rules. Points that are within 6 cm of A, but at the same time, it's also 5 cm from D. So it will be the small region of intersection here. Okay, anyone has any questions? Okay, no, you can start drawing. So you stand on A, measure 6 cm, stand on A and draw an arc, and then 5 cm of D. Then you measure 5 cm, stand on D, and then you put an arc, and then where the region of intersection is, you shade it. That will be locus of points that obey that rule. Okay, can I have a show of hands of those still doing? Okay, I'll give you another 1 minute and then we will go on to the next one. So if you're done, turn to the next page and draw another triangle, same triangle, A, B, C, D. Okay, let's go on to the next one. Number 3, shade the locus of the points inside the rectangle closer to A than they are closer to D. Okay, points in the rectangle that are closer to point A compared to point D. So let's see.
Chair,
Yes,
is locus mainly about perpendicular bisectors only?
it's not perpendicular bisector. Perpendicular bisector means it's 90-degree and it cuts a line into half. So it's not about perpendicular bisectors. It's about using similar construction methods that we learned in the topic construction to find out possible other points. But it's not perpendicular bisectors. Remember,
Oh, okay,
perpendicular
chair.
bisector is bisecting a line into half at 90 degrees.
So will this come out for exam?
I'm not quite sure. It's either this or construction, one of it.
Okay.
Yeah.
So JJ, you still haven't got the exam scheme yet.
We are in the midst of finalizing it lah. How to what is that? Conduct it.
Chair, when will all the exam topics all will be given out?
Once we finalize everything, we're in the midst of finalizing it, then we will give it to you.
Okay, chair.
Okay, so let's see. Points inside rectangle closer to point A than point D. So I have an arc. I have another arc. And then I draw the points that intersect. And it's the region which is on the left-hand side. So the points here will be closer to A than they are to D.
It can be any length, teacher.
Sorry?
It can be any length.
Yes, but a big one. So more than half. Closer to B. So take a measurement that is closer to B. So you stand between A and B and then decrease it slightly and then you draw the arc.
For example, we take something like 6.5 and then for D you can take maybe 5.3 or something.
No, for D it will be the same length.
Oh, for D it's the same length.
Yeah.
Okay.
Use the same measurement.
Okay, Jack.
Okay, all okay so far? Anyone has any questions? Okay. Make sure you write the sentence down there so that you know what exactly you're doing. And then if you're done, turn to the next page and draw another rectangle.
Teacher,
Yes.
how is locus important?
If you want to find, let's say you're given a situation where you it's not a situation in terms of drawing, but let's say you have a real life situation where you have many possible outcomes. Okay, possibilities of different outcomes for a certain situation given, for a certain certain condition given. So there's so many possible solutions. Okay, it's not just one solution. So this is where locus comes in. So locus just basically gives us a concept, an idea of where when a rule is placed in any situation, there is based on that one rule, the rule tells us what not to do or what to do, but it doesn't tell us, and it gives certain boundaries, but in that boundaries there are many possible solutions, there are many possible outcomes. So for example, have you all played the game where you take tissue paper, toilet paper, the toilet rolls, and then you wrap someone around like a mummy? Have you all played that game before?
Yes,
My
Cher.
mom would skin me alive.
No lah, this is like a game lah. So usually when you go like team building games or whatever, right? One of the games sometimes is like you take paper rolls, paper towels, and then you wrap it around someone, and then and you only have a limited number of rolls, maybe 5 rolls or 10 rolls, and you have to wrap the person like a mummy. So that's the rule. They only give you that as the rule. You have to wrap the person around, wrap the person fully lah. But there are many possible ways. If you see, different groups will wrap them differently. There are many possible ways of wrapping the person. Number one, they can wrap the person from toe to the head. That is one possible solution. Another possible one is from head to toe. The third possible is you wrap them maybe in the waist first, and then you go upper body, and then you go lower body. That's the third one. The fourth possible, another group might do it so creatively that that they wrap the mummy in such a way that you just, so one group will just wrap the whole thing. Some groups will wrap each part of the body separately. Maybe the head, okay, tightly wrap it, and then the body, you wrap it again separately, and then the hands, you wrap it separately. So there's so many possible outcomes into wrapping the person. But the rule that was given was cover the person with toilet paper, like a mummy. So there's so many different outcomes. So locus is just helping us understand that concept. So when you go into the working world as well, right, and you're given a problem. Okay, you're given a problem, you're like, okay, this is a problem and we have certain things we cannot do and we need a solution. So, and then there's, let's say, 5 people in your team. So everyone will come up with different possible solutions because there's many perspectives to look at, many different possible ways to look at it. So locus just helps us understand that and gets our mind to a place where just because a rule is stated doesn't mean that there's only one possible outcome.
Understand, Chair.
Yeah.
Yeah.
Mm.
So how do you come to understand what the question is asking? Because I don't really like grasp what they are trying to do and what to do when they ask me to do it. Like, how do you understand what they are saying?
As in like these questions?
Yeah, because like in each of that there's a different method, right? So like I don't know what to do in each question.
Oh, okay.
I know how to do it, but I don't know what to do.
Okay, so basically you just have to look for rules, boundaries that they set. So in this case, right, for example, okay, let me take the previous example. Okay, so for example, this one, right, we look for the boundaries given. So it says, I want points that are within 6 cm of A. That means it has to be within 6 cm from point A, that's boundary 1, and then it has to be within 5 cm from D, that is boundary 2. So I draw the boundaries separately, okay, based on our understanding of it, and then I see where they intersect. In this case, there are 2 rules. So I want to be able to satisfy both rules. So I draw the rules separately and see where they they connect with each other, see where they overlap with each other. And in this case, you will get a region lah. So what you want to do is you want to draw the rules separately. You want to outline the rules separately. So in this case, you draw the locus of points within 6 cm first. And then from D, you draw 5 cm. It's 2 separate rules. But then there is an outcome where there will be a region that satisfies both those rules, and that will be the middle lah. So how you want to tackle these questions is you look at the rules separately, draw them separately, and then look for an overlap. And then there will be a region of points lah. Okay. Okay, let's move on to the next one. Shade the locus of the points inside the rectangle closer to AC than they are to CD. Okay, so again, I draw the boundary that is given. So I want locus of points inside the rectangle that is closer to AC than they are to CD. Okay, so I draw a small arc. I stand on C and draw a small arc. With that same distance, I stand on this point and make an arc, and this point and make an arc. I draw a line. Okay, and then that region, the points in that region will be closer to this line compared to this line. Because remember, this thing is a rectangle. Okay, if it's a square, then I will have all of it equidistant to a certain extent because they're all same length. But in this case, CD is much longer than AC by 2 cm because it's 8 by 6. So I have a certain point in the region here where all these points will be closer to AC compared to CD. So all these points here will obey this rule.
So can I do what you just did from A?
Can you do what?
Like you draw the arc all at A.
Oh yeah, can? Yeah,
Can,
it will be the
okay.
same thing. Yes, correct.
Okay.
Okay, so you can draw from A, you can draw at A, you can draw at C. Okay, but the thing is why we draw at no, actually you cannot draw from A. You know why? Because if you draw A, if you draw at A, you will get a line that is like this. Let me draw. You'll get roughly lah, you'll get a line like this. No. I must go through point A. Okay, you'll get something like this. But the thing is,
but then how do you know whether to use A or C?
you look for common. Between A and C and D, which is the common point? C. Between AC and CD, the common between the two is C. So point C will be your point of reference.
Okay.
Okay, so I have a small arc here. With the same distance, I cut another arc, I make a line, and then I shade.
Cher,
Yes?
is the locus used in architecture, Cher?
Is locus used in architecture? Oh, I wouldn't know. I'm not too sure. Let me think about it. Yeah, possible if let's say we were to draw draw a a picture of how a building is going to be or how a landscape is going to be. And let's say the person that hires you is like, okay, I want you to design for me a model that will have a building, no, let's say a condominium that is built on a land, and the land must have a lake, the place must have a playground, and then it must have a gym, it must have a restaurant and all these things. So let's say I'm the person and I'm like, okay, I want you to build me a model of a landscape, and I want that landscape to have a lake, a playground, a gym, a restaurant, and what else can I think of? Yeah, let's say I want these things. So there are many possible ways of how the architect can build a model, whether he wants whether so I only say these things, but I don't say, okay, the lake has to be 10 cm away from the playground, or 5 cm away from the restaurant, or I want the restaurant to be on the lake. So there's so many possible ways of coming up with a model that will obey those rules, where he wants a playground, he wants a lake, he wants a restaurant, he wants a gym. Because he doesn't give me these rules of like, oh, this has to be a certain way. So people who have visions, they tell other people, okay, this is my vision, but they don't give rules like, okay, I want this to be a certain way. So these people who are working for the person who gave the vision will come up with different ways that will fulfill the vision. There's always so many possible ways. So this architect comes up with different models, and then the person picks the model that he thinks he likes best. That is in terms of like having so many possible ways of doing one thing. Does that make sense?
Yes, Cher.
Sir,
Yes.
is it possible to calculate future outcomes using mathematics? Sir?
Yes. Future possible
Oh,
outcomes can.
do you know
Will
how
I
to do
get
it?
it? Will I cover all possible outcomes? Highly possible. But at the same time, because when it comes to maths and science and just knowledge in general, there is no boundary. So will I cover every single outcome? Maybe, maybe not.
There are infinite possibilities.
Yeah.
Hmm.
Okay, let's move on to the next one. I think this is the last one, or the second last one. Oh, hang on. Okay, so shade the locus of points 3 cm from the rectangle. Okay, from the rectangle. So I will have points that are 3 cm from the rectangle outside. Okay, so draw your last rectangle, write this out, and then you take a ruler, you measure 3 cm from maybe point C, point A, point B, point D, and then maybe from the middle here, and then you can draw a region like this.
Sure. Sure.
Yes, yes.
So could you stop recording for a while, Acha? I'm trying to get back in, but then the but then my screen is not enlarging. Oh, in Namacha, it just
Okay.
enlarged.
Okay. Okay, can I see a show of hands for those who are still doing?
So I'm still doing it.
Okay. Okay, those who are done, you all can go for a quick break. Come back at 10:30. Okay, and then we will do, yeah, I'm supposed to cover one more, but we'll see. I will see if I can do the circle theorems question or not. I have to see. Okay, so come back at 10:30. Okay, we're going to do a little bit on the last part of the syllabus for the term. And then hopefully we can go through some of the circles questions next week lah, if we cannot do it, because after today I won't have any more new topics. Hopefully we can go through it together next week lah. So if you have any questions, I will try to answer you on Edmodo. If not, we will wait for next week's class, but please try to do as much as you can first, and then when it's class you ask me the ones that you are unsure of lah. So next week onwards we will just be discussing questions and preparing for exam lah, whenever exam may be. Okay, all okay?
Yes, sir.
Yes. Okay.
Yeah.
Let's look at this. Okay. Compound measures. Okay, everyone can see my slide.
Yes, sure.
Yes. Okay.
Yeah.
Okay. We want to look at conversion between units, converting money using exchange rates, and answering some exam style questions. Okay, you don't have to copy this down. Just give out your answer, okay? So I have 5 miles is equals to 8 km. So what would 10 miles be?
16.
16? Okay. 5 miles is 8 km. 20 miles?
32.
32 kilometer. Because 5 to 20 will be times 4. So 8 times 4 is 32. Now, if you have no clue like how to do it, please like speak up, okay? Okay, next. 15 miles.
24.
Why 24? I times by
3.
3. Because 5 to 15 is times 3. So I also times 3 for 8. Okay, so it's like 1 apple is 5 ringgit. 5 apples is 25 ringgit. So in this case, 5 miles, so 5 apples is 8 ringgit. So 10 apples will be 16 ringgit. 15 apples will be 24 ringgit. So I'm just using ratio. Okay, so 5 miles is 8 km. 15 miles, 10 miles will be 16, because time double. 15 miles will be 24.
So must we copy the conversion unit?
No need to copy. Pooja, can understand? Okay. 45 miles. So 5 miles is 8 km.
72
So,
km.
Yes, so 5 to 45 is times 9. 5 times 9, 45. So 8 times 9 is 72. Okay, let's see the next one now. 5 miles is 8 km, 16. So 16 is not in time table 5, but how do we calculate for 16?
So is the answer 25.6 km?
Okay.
I
I
got
need Tell
105.6
me how to
km.
do. So it's like 5 apples is 8 ringgit. How about 16 apples? So what I want to do is I always calculate for 1 first. So 5 miles is 8 km. We calculate for 1 mile first. So 1 mile is how many km?
Teacher,
Mm.
for the 16 km one, oh wait. Oh, it's 10 miles. 10 miles.
Okay, so what you want to do is you always want to find for 1 mile first. Okay, so 5 miles is 8 km. So 5 apples is 8 ringgit. 1 apple is 8 divide 5. 8 divide 5 is 1.6. So 1 mile is 1.6 kilometer. So 16 miles will be, you times 16. So 1.6 times 16, you should get 25.6 miles. Abigail can understand?
Yeah.
Isaac?
Sure.
Yes.
But this one is changing km to miles, teacher. So isn't it supposed to be times 2?
Oh yeah, sorry. I made a mistake. Okay, so 5 miles is 8 km. So 16 km will be how many miles?
10.
10 miles.
10 miles. Because 8 to 16 is times 2. So 5 times 2 is 10. Okay, sorry, I made a mistake. Okay. 24 km,
15.
15 miles. Because 8 times 3, 24. So 5 times 3, 15. 40 km,
25.
25. Because
25
8 to
miles.
40 is times 5. So 5 times 5 is 25. Okay, 88
55 miles.
25.
times 11. Okay, 8 km is 5 miles. 1 km?
1.6 miles.
1.6.
No, 0.625. Because 8 now is 8 apples is 5 ringgit. It's the other way around. 8 km is 5 miles. So 1 km will be
0.625.
so 0.625. Okay, 1 mile will be 1.6 km. Okay? Okay, we won't do this. Okay, let's look at this. Katie has 2 pounds. She changes all her money into dollars. And we know that 1 pound is $1.65. So if she has 2 pounds, how many dollars does she have?
3.3.
What do I do? You have to tell me what you're doing. Don't give me answer.
1.65 times 2.
Times 2. So how much do you get?
3.3 or
$3.3.
$3.30.
Yes. Okay, let's look at the next one. Okay, I'm going to call out some people. Okay, Kavishka. Ryan has 100 pounds. He changes all his money into dollars. How many dollars will he have? 1 pound is 1.65. 100 pounds?
$200.
Sorry?
$200 actually.
200 pounds. 1 pound is $1.65. Now I have 100 pounds. So how many dollars would that be? It's like 1 apple is $1.65. Now I have 100 apples. So what do I need to do?
Times it actually.
Times by what? What times what?
100 times 1.65.
Correct. So what do I get?
165.
Yes, so $165. Okay, Joe has 55 cents. She changes all her money into pounds. How many pounds will she have? Let me call Ricardo. So it's the other way around. The conversion is now the other way around. Sorry?
0.3.
Correct. 0.33 dollars, sorry. Okay, let's look at this. Sam returns from Germany with 65 euros. He changes this back into British money at a rate of £1 is 1.42 euros. So he comes back with 65 euros. How much did he get back?
So is this a general question, Ajay?
Yeah.
Okay.
So I
you
have
get,
the conversion
you
£1.
get, you get $92.30.
No. I have £1 is equals to 1.42 euros. Now I have 65 euros.
Which
So
isn't pounds and euros the same?
No.
Oh no.
No.
How is that euros and pounds are the same thing?
No, different.
So is it 45.77?
Correct. 45.77.
Okay.
Now let's look at this. Dave returns from Switzerland with 55 Swiss francs. He changes the francs back to British. I think it's francs. He changes the francs back to British pounds at a rate of £1 is 2.32 francs. How much does he get back?
23.70.
What do I do?
You divide it.
What divide what?
The Swiss francs divided by the 2.32.
Yeah. So 55 divide 2.32. What do I get?
23.70.
Yes. 23.7 pounds. Okay. Okay. Anyone has any questions so far?
Sure.
Yes.
But what if you get an answer like 23.70689?
Then we change it to 2 decimal.
Okay.
So 23.71. Because when we look at cents and all, we look up to 2 decimal anyways. And
Yeah.
this is also 2.32 francs. So it'll be 23.71 lah in this case. Okay? Okay, so this is another important part. This is very useful for maths and for physics. Okay, so let's skip this. Okay, so I have speed equals to distance over time. Okay, speed is equals to distance over time. So if I were to put it in a triangle like this, okay, if I want to calculate for time, okay, I cover time. If I want to calculate for time, I cover time. So it's distance over speed. If I want to calculate speed, I cover speed. So it's distance over time. And if I want to calculate distance, whatever you want to calculate, you cover that in the triangle. Speed times time. Understand? Does everyone get that?
Yeah.
Sure.
Yes? Okay.
Check copy.
Yes, please copy very quickly. Draw the triangle, distance, speed, and time, and then write these 3 formulas. Very quickly, I give you 1 minute. It shouldn't take too long. Okay, let's look at the next one. Okay, mass, density, and volume. So same thing. Okay, very quickly. If I want to calculate density, what's the formula?
Density equals mass over volume.
Okay, if I want to calculate volume,
Volume equals
Volume
mass
del-
over density.
okay, and if I want to calculate mass,
Mass times density. No, mass equals density times volume.
so basically you just like similarly you cover what you want to look for.
Which you can
Yes.
I copy that, Rajan?
Copy the triangle and write down the formulas. Mass equals to what, density equals to what, volume equals to what.
So can you do one for moment now?
You can do it by yourself, based on, so whatever let's say moment equals to force times perpendicular distance, right? So what you want to calculate is always at the top. So moment is at the top, and then force is here times perpendicular distance from pivot. So what you want to calculate is always at the top, as in like the general formula lah. If it's a times. So moment equals to force times perpendicular distance, right? So force times perpendicular distance. That's for moment lah. Okay, quickly copy this down and write the three formulas first for mass, density, and volume. Okay. Okay, so let's try this one. These questions. A piece of metal weighing 40 grams has a volume of 4 cm cube. So what is the density? So Kavishka, how to calculate for density again based on the triangle? Density equals to what?
Density equal mass over volume.
Correct. So you take your mass 40 and then divide by the volume cm cube. So 40 divide 4, you get 10 gram per cm cube. So that will be your density. Okay, what is the volume of a piece of rock that has a mass of 72, density of 9? So if I want to calculate volume, Abigail, how do I calculate for volume?
Density over mass.
Look at the triangle again. I want to calculate volume. If I want to calculate volume, I cover volume.
Mass over density.
Right. So I take the mass 72, I divide by 9. So I get 8 cm cube.
Yeah.
Okay. Okay. Three questions here. Quickly do, and then we will look at the answers. You just have to, you don't have to copy the questions, just get the answers. And then we will see what they are. Okay, let's see the first one. What is the density, Ricardo?
2.5
Can you tell me
grams,
what did you do?
60 cm. Yeah, no,
Sorry?
150 grams divided by 60 cm.
Yeah. So we get 2.5. What is the unit?
Grams per cm cube.
Correct. Okay. Second one. Let me call Malcolm. Number 2. What is the volume? Or how to calculate volume? Malcolm, are you there? Okay, yeah. What do you get for volume? What divide by what, or what times what? Yeah, it's okay. Yeah, your mic doesn't work. You just tell me in the chat lah. How do I work out the volume? Okay, you can work on it. I will ask for number 3. Judith, what is the density? Number 3, Judith.
Give me a moment, chat. Actually, I'm just finalizing the answer. All right, the density is 1.96.
What did you do?
40.7 divided by 7.5.
Okay, so I get 1.96. What is the unit?
Grams per centimeter cube. Sorry, sir.
Yeah. Okay. Malcolm, back to you. What is the volume? No, not 1.3. So it says volume. So volume means I cover volume. I should get mass over density. My mass is 15 and my volume is 19.3. So 15 divide 19.3, you should get 0.77 or 0.78.
cm cube. Okay? Okay. Okay, very quickly, volume of cube and cuboid. Length times width times height. Okay. You don't have to take down the pictures. You can just write down the formulas, okay? So that when you have, you can always refer back to this formula. So quickly copy down the volume of cube and cuboid is length times width times height.
So class ends at 11, right?
Yes.
Okay.
5 minutes. Okay, and then we have next, which is triangular prisms. Triangular prisms is base times height and divide by 2. Basically, it's half times base times height, which is your triangle.
Divided by 2, Acha.
Yes.
Can I write base times height over 2?
Yeah. Okay, triangular prism is base times height over 2. We have the next one, cylindrical prisms is pi r square h.
All this coming out for exam.
No, I'm not sure which shape is coming out, but volume and perimeters are coming out. It's not, but which shape, I won't tell lah, but you must be able to find. I will give more details on what exactly, like what to narrow down to lah in once they release the.
It's r squared doesn't it mean the diameter?
R square is no, diameter is 2r, 2 times the radius. R square is radius times radius. Diameter.
Isn't the same thing, Acha?
No, see, for this circle, right, the first one, the diameter is, radius is 4, diameter is 8. R square.
Oh, okay, yeah.
Square, which
So
is
be 16.
okay, wait, someone asked me to change to the slide before. Triangular prism is base times height over 2. Okay, and then we have cylindrical prisms, pi r square h. Okay, r is radius, h is height. And then I have volume of sphere, 4 over 3 pi r cube, where r is the radius. Volume of this is not a sphere, this is this is called a cone. Let me just. Okay, volume of a cone, 103 pi r square h. And you have to remember that h here for a cone is the height, the perpendicular height from the tip to the center of the circle, not the diameter. So you have to be careful. How you can get the height? Let's say you're given the diagonal, and you're given the radius. So you can use Pythagoras theorem to calculate the height. Let's say you're given the slant, which is the hypotenuse, and the radius, then you can find the height by Pythagoras theorem. Okay, so that is all for today. I will post some questions, and then next week onwards we will discuss on, we'll discuss on circle theorems and revise on other things as well. Okay, any questions?
No.
No? Okay.
No, teacher.
Then have a good long weekend.
Okay,
You,
Jaya.
teacher.
Bye, Jaya.
Bye.
Bye, teacher.
Teacher.
Good night.